Alright, so from last lesson, 5.2, we learned about annuities, and that's where you make regular periodic payments. The present value for an annuity must be equal to the future value of that annuity grown over the same amount of time. So if I'm making payments for 10 years, and I end up with a certain amount, then the present value would be equivalent to if I just took that principal and then let it sit there and just that lump sum earned interest for the same amount of time. So present value is lump sum earning interest for a given amount of time. Annuity is making regular payments, each of which earns its own little bit of interest on interest for the same amount of time. To get the formula for present value, it just is what starting value would allow that. So what you do is you multiply both sides by this, and then that gives you that. As you distribute that in, it's this times that, and this times the -1. Simplifying with your exponent rules gives you this. So that's just where that formula comes from. I used to do that proof out in class, but I don't. I just wanted you to at least see it. So for the amortization formula, that's just if we take the previous formula, this one, P equals that, and solve for R instead. So we'd multiply both sides by the reciprocal of this, and that gives you this for the amortization formula. So basically, if you're paying off a loan, all right, P is the big interest payment or whatever, and then, or that's the big starting amount, and then I is the rate over N, and this N is N times T. So really it would be the present value times R over N all over 1 minus 1 plus R over N to the negative NT. So aren't we glad we used the TVM solver, because you don't actually have to use that formula. If you like the formulas, that's what you're going to use. So this is in another video, so I'm going to skip that now and go to the next piece. So the examples, I'll do those in another video.